Of course, hotter years have more fires. Forests become drier. The underbrush in those forests becomes drier and is more prone to ignition from lightning. Another impact of a higher temperature, for every 1 degree higher temperature, there's an 11% increase in lightning strike activity. Lightning strikes are often the source of forest fires. We saw the horrible fires in California that killed 86 people in 2018, burned over 14,000 homes. This was in Switzerland in 2003. This was in California, 2018, again, a very apocalyptic scenario. Australia last year, as you know, experienced horrible fires. But these fires, it's important to understand, there's a double whammy, because the carbon that is locked in those trees, in those forests, is burned and released. It's estimated that 500 million tons of carbon was released in the wildfires. That carbon dioxide goes into the atmosphere, causes more warming, causes more fires. So we get into this issue of climate feedback. This was a large set of fires last year in Russia. In fact, so large you can view them from space. And globally, the insurance companies, if you're a capitalist and you simply are looking at this from what is the cost to our economy from this, there is a real economic cost. When carbon dioxide is released, it has these impacts, and therefore it has a real cost to society. Just in the US alone, it's estimated the last 2 years, $650 billion of damages. So I think, as David Attenborough has said, we understand the physics of carbon dioxide. We understand what is happening with warming. The data supports the hypothesis. One other very important data point I would like to give you is that we saw that there is a natural variability over 800,000 years in both carbon dioxide and temperature. So it's always changed. How do we know that it's us? How do we know that it is human beings now? The reason we know is that if you analyze the carbon in the atmosphere today, approximately 1 out of 4 carbon dioxide molecules, the carbon can be dated. And that carbon, and 25% of what's existing in the atmosphere, is extremely old carbon, millions of years old, which means the source has come from human beings digging the carbon up as coal, oil, and gas, burning it, and emitting it into the atmosphere. So there is no question about the responsibility for the higher concentration. It's human activity. And that's a good point to bring in the Paris Agreement. The Paris Agreement, as you know, was a wonderful achievement to get every country in the world to agree on anything. Let's be honest, that's quite an achievement. And the scientists had told us in the Paris Agreement that we need to limit warming to this 2-degree threshold. And I think that is quite important, and that poses some risks for investors, which I'm just going to touch on. So Paris, almost every nation in the world agreed to work together to cap emissions at 2 degrees. Now, the reason we have warmed the planet by 1 degree, 1.1 actually, we're getting close to 1.1 now. So we have this sort of 9/10 of a degree remaining. Why is it so important that we keep it below 2? I have spent now a huge amount of time reading academic peer-reviewed research on all aspects of climate change. In the summer of 2018, I attended at the London School of Economics. They have the Grantham Research Institute on Climate Change. There's an executive education program there, which I attended. And I'm very pleased to say that Sam Fankhauser, who runs that, Professor Fankhauser, now sits on our advisory board at Carbon Cap. But one of the things that I've spent time researching is climate feedbacks, positive feedbacks. This is one of the main reasons scientists have said we must limit the warming to a maximum of 2 degrees, or even better, 1.5 if we can. I'll give you an example of 2 of these, and it's not a very happy story, I'm afraid. And in fact, when you actually understand these climate feedbacks, it's particularly not a happy story. I'll give you an example of two feedbacks. Arctic sea ice has been in massive retreat in the last 30 years. We know that. Ice is white, and therefore when solar radiation from the sun comes in, it hits the ice, and a white surface reflects. When that ice melts and is no longer there, that solar radiation hits soil or water, and that heat is absorbed. It's like when you go outside with a dark jumper on, you feel the solar radiation turning into heat energy. So as the Arctic ice retreats, more heat is generated from the incoming solar radiation. That generates melting, that melts more ice, and we get into this feedback loop. And you can see it's not really a positive scenario at all, even though it's called a positive feedback. Second one is on land. Now, in the northern Canada, northern Russia, there's approximately 1.8 billion tons of CO2 and methane locked in the permafrost. Permafrost is the soil area that is 1 meter below the surface. It never unfreezes. Even in the summertime, it stays frozen. Of course, as the planet warms, that permafrost line is moving about 100 kilometers north every decade. That means that permafrost, those clathrates of carbon dioxide and methane that are locked, they are released and they further warm the planet, which pushes the permafrost line further north. One of the real worrying things is that methane itself is a global warming greenhouse gas, but it has 28 times the potency of CO2. And there is approximately equal to, within this permafrost region, the equivalent of all of the CO2 that we have released, that mankind has released, is locked. And that is just one of many of these feedbacks. So you can see why we must listen to the scientists, why 1.5 and 2 degrees are thresholds that we must not breach. If we do, we risk going to 3, 4, 5 degrees. And at those levels, we really are living in a world that is fundamentally changed. The scope of the challenge is immense. The blue line is historical emissions. This is, in my view, this is the biggest supertanker in the world. It's very hard to turn that around. Carbon dioxide emissions are everywhere you look, everything you touch, and therefore to move from that is difficult. If you add up all the pledges, the nationally determined contributions that were made in Paris, you get the yellow line. So Paris was good, but Paris leads us to a 3-degree world. A 3-degree world is not a future you want for your children and your grandchildren, because it probably leads to 4 and 5 degrees due to triggering those feedbacks. But you can see the pathway for 2 degrees and 1.5 means we require cuts immediately, not stabilization of emissions. We need emissions to stop growing and to begin coming down. By some calculations, and I look at I take the UN Environment Program, we need to get on track for net zero emissions by 2050. And that means between now and 2030, we need on the order of 5 to 7% a year reduction in emissions to be on this pathway. Now, this brings us to the risks for investors, and I'm just going to touch on a few things here. The UN Principle for Responsible Investments, the UNPRI, has put out a paper called The Inevitable Policy Response. And in this paper, they're really trying to highlight the risk. As these climate change-related risks become more aware, Mark Carney, the former governor of the Bank of England, and others are worried that when this really becomes aware to investors, it may precipitate a financial crisis. And what the PRI is doing is they're recognizing that perhaps a lot of these risks are not priced in, and that when the Paris Agreement calls for a stock take to take place in 2023, And based on current information, I can tell you we're not doing that well in meeting our objectives globally on emissions. And there may be then a backlash and a policy response that is then disruptive for capital markets. In other words, you don't want to be holding fossil fuel related equity and debt at that moment if that happens. So it could resound through multiple asset classes, and really what's important is disclosing these climate related risks. There's a multitude of different risks. It's not only physical risk from flooding, water scarcity, etc., impact on your labor force, but it's the investor behavior. We're seeing BlackRock was announced. They've joined Climate Action 100 only a few months ago. That organization makes up 41 trillion now of assets under management and requires companies to increase their disclosure on climate change related risks. Also, they will not invest in companies where more than 25% of the revenues are derived from coal. And coal is one of the worst offenders, as I'll speak about in a few moments. So understanding climate change from an investor's point of view is a risk management. It's becoming a very important risk management exercise and a risk management issue.